Often it happens that application developer or a solution developer reaches to the other team, let's say a platform team, and asks them for minimum set of APIs or libraries or SDK. So in that case, what platform team does is they provide a proxy. They provide a set of wrapper classes. So the library they provided is just a proxy. It doesn't contain the core logic, the core implementation. So there could be many scenarios. Okay, many scenarios why they don't give the actual core implementation. But this is the ultimate reason for having a proxy design pattern. So what actually proxy design pattern does is basically, if you see this class diagram, is in this design pattern we have one interface class, and from that interface class, which contains many of the pure virtual functions. Okay, and all those functions, pure virtual functions, are implemented by two derived classes. Okay, at least two derived classes in the overall high level logic. So here we have one is proxy class and another is concrete class. Okay, so what proxy class does is this implements all this APIs, but it doesn't implement any of the logic, whereas the concrete class implements all of the logic here. So when proxy APIs are being called, which is the only accessible set of classes to the client, not the concrete class. So whenever a client calls proxy APIs, these APIs internally calls concrete implementation APIs. Okay, and they get the core logic solved. Okay, and the result back to the proxy object, and from proxy object it goes to the client. Okay, so that's how it works. So I said there could be many reasons why this kind of design pattern is being used, but the fact is this design pattern is very widely used, is very much common. And the reason I could few of the reasons which I could state are like, this concrete implementation contains some of the proprietary logic, proprietary implementation, which the vendor doesn't want to expose to the other party. They want to keep it hidden, and that's the reason they have provided proxy only. Okay, and they hide this whole their logical implementations inside. Other could be like they want this to be completely separate so that they can upgrade their internal implementation every now and then without troubling the client or the application implementation. So application will be independently working using this proxy classes. Okay, and this platform team will keep updating whatever they want to. Okay, so they want a loosely coupled relation between this concrete implementation and the main client class. Okay, so that's the reason they have introduced proxy design, proxy in between, proxy classes in between. Okay, now we understood why it is, how it is, and all. So we are going to see the actual coding part of it. So if we go and just a second. Yeah, so if we go and see the classes here, so we have one uh, interface class. Okay, the daemon is in base class or interface class here, which contains many of the pure virtual functions. So it is an abstract class ultimately, and from there are two classes, daemon concrete and daemon proxy, which are derived. Okay, so as we've seen in the class diagram, so daemon concrete does the actual logical implementation, the core implementations. So we have introduced only one API here in the abstract class, just for the simplicity. So this API is get version, and in response we get a string which contains the version of the platform. Okay, so this is similar API which I had used in many of the design pattern, just to concentrate on design pattern rather than the core logic here. So anyways, so here daemon concrete does the core logical implementation here. Okay, so it gives the platform version as 11.5. Okay, and here in daemon proxy, in this which also is derived from daemon, okay, the abstract class. And what it does is it contains a strong pointer for daemon concrete. And whenever any API is being called from the client side or application side, what it does is this does the further query to daemon concrete, so using this strong pointer. So here in this case, get version, in daemon proxy get version, it ultimately calls to concrete get version. Okay, and concrete get version contains the actual complete implementation. So here, in future, suppose the version changes. Okay, so this doesn't require this SDK to be updated all the time. Okay, so what they will do is in platform part and the concrete part, they will change the version, and proxy will be unaltered here. Or if they implement some kind of logic or implementation change how they are going to get this version, still they doesn't affect the proxy implementation. And so the call here, the main class or the client class, we can say, so is not affected by the internal changes. So this is how the code is implemented. If we execute this application, let's see here, we run it, it's compiled, and we are getting 11.5 as the version here at the client part, which is actually coming from concrete via proxy. So that's how the proxy design pattern is implemented. Thank you.